Moving on in our program, we have now gotten to the agenda point, an introduction to Qt Quick and Qt Quick controls. A lot of what Andy has been talking about now and enabling Qt on embedded devices is only as interesting as the UI on the device you're able to create. So my colleague Gabriel will be giving us an introduction to that topic. But before I'll give the reins to him and allow him to share his screen, just a few notes. We are recording this session, so if you're interested to hear this at a later point, you can drop out, and we will send you an email. I guess on Monday or very early next week with links to all of the recordings that we've done today. Those you can share with your friends and family and anyone else interested in Qt application or device creation, application development. For those of you who have just logged in, I'm happy to take questions in the Q&A pane in the WebEx tool. So write any questions you have there. We'll try to answer questions as we go along. I'll summarize a lot of the questions, or write down a lot of the questions, and have Gabriel answer them at the end of the session. What fits into the presentation, I'll try to take in the middle of the presentation. So we'll try to get all of those answered. But what we don't answer during the session, we will try to get back to you later when we send out the summary of the event and the recording. But feel free to send us an email if there's any technical questions you might have. And in addition to that, we're also drawing an iPad as a prize for one of the people listening in. So stay tuned for who of you who are actually listening in is going to win that iPad. That will also, I think, be made known on Monday. Now it's Gabriel. After that, we'll also have a talk about Direct WebGL in Qt Quick 2, and from 6:30 to 7:30 CET. An introduction to and deep dive in Qt Web Engine by my colleague Pierre. So if you're interested in any of those, tune back in later or stay tuned now, and I'll try as best as I can to hand the reins over to Gabriel. Let's see if he is now able to share his screen. Welcome, Gabriel. How are you today?
Hi, fine, thanks. I need to show my desktop. And let's see, are people see my desktop now? Yes, yes. So, welcome. And yeah, so let's start with this introduction to Qt Quick controls. It's more oriented towards Qt Quick controls rather than just Qt Quick, but it's all the same. This is going to be a live stream session, and again, I hope you will enjoy it.
I think we will.
Thanks. So a few words about me first. I've been working on Qt since 2009. First at Nokia, then Dietrich, now at the Qt company. I've always been part of the UI team over those few years because I'm a pixel perfectionist, and the best way to get pixels right is to make you themselves. Right now, currently, I'm working on both Qt Quick controls and the Qt port. And the second part is a bit of irony when you see sometimes the few embarrassing bugs we still have in the Mac style. But we're fixing them one by one, and we'll get to something satisfactory at some point. I live and work in Oslo, Norway, with still some of the original trolls around. Some are rather new too, but it's a nice office to be and a nice place to be. And as you may have guessed from my accent, I'm not an English native speaker. I'm half Russian, half Spanish, so bear with me if I come up with some new English constructions. And so during this presentation, we'll see how to implement UI with Qt Quick controls, how to interface QML with C++, And finally, how to create a QQuick-compatible model, and we will see why that is useful. So here's the UI we plan to implement today. We have a main window. Main window has a toolbar, a few controls inside that toolbar. The content area of this window has a split view. Split view, for those who don't remember, is this thing you can drag around and resizes left and right. The left side of the split view will have an image view, and on the right side we'll have a tab view, which has two tabs, one showing a table view with some data, and another will be showing a histogram view, which is our own custom view. So for those who don't know, a histogram, let's suppose we have a grayscale image, and a histogram is just counting how many pixels have which intensity. So how many pixels have intensity 0, how many pixels have intensity 1, and so on, up to 255 if that was an 8-bit grayscale image. An RGB histogram does the same thing, but for its red, green, and blue channels separately. So let's start with this. Let's start coding it. And so this is some template code. This is what you get already when you create a new QQuick application from Creator. So this, again, this is template code. So what you have here is our main CPP with the main function. It creates a Q application. It instantiates a QML application engine. Basically, this is a QML engine with some extra bits. And it loads the main UI file. We recommend to have it in the resources file. All your QML files in the resources file. And then, yes, and then it runs the application. And so this main QML file, this is also part of the template we've seen, is just here. The main window is the application window. It has a menu bar with a few menu items here, and it has in the middle some text. So if it's involved, let's run it. And this is what we get. We get main window, some text in the middle, and that's about it. Well, this is very primitive, so let's try to populate it a bit. Let's say we have, instead of some text, we'll have a button. And when we click the text, since it's a polite button, it will say thank you. So thanks for clicking. Now, to run it, we have this button in the middle here. And when we click it, you can see at the bottom here in the console output that it's really doing something. Now, if you look closely, you will notice that this button looks, for those who know the Mac platform, I'm running a Mac, by the way. For those running the Mac platform, will notice that this looks as a Mac button. And actually, we're doing in QQuick controls by default on desktop the same thing we did in widgets. That means that buttons will look like Mac buttons on Mac, will look like Windows buttons on Windows, and will look like whichever flavor of Linux you have, or Linux desktop you have on that Linux desktop. So this is not the UI we want to implement. We want something a bit more elaborate. Let's start with the toolbar. Let me remove this button. Let's start with the toolbar. The same way application window has a menu bar, property has a toolbar, and we assign a toolbar object to it. The toolbar has a tool button with an icon. Let me copy the icon here. And also have a slider. And we said also we had split view as main content. So we declare the split view, and we're going to make it feel its parent. So the parent for the split view in this case would be the application window. content area. The split view had two children, an image view, let's call it picture for now. We'll populate it later. And I had a tab view as well. The tab view, let me add a few lines at the end of the file so that we have a bit more space. So the tab view had two tabs. One was for the table view, and the other tab was for a histogram view. Now, table view, we can fill it later, but we will have something to show already. So let's run this and see what it looks like. Well, we see a few problems already. We see that here the toolbar is not quite right. The tool button and the slider are overlapping, and we see that the image view is nowhere to be seen. And there are a few problems with the margin. So let's fix them one by one. The first thing to know is that toolbar is just a container, but it doesn't know how to lay out its contents. It just provides some styling to some background, and it makes some room for the application window to leave space for the rest of its contents. So what we want to do here is just put this tool button and slider in a layout this button and slider in a row. For this, we have another import, which is QQuick layouts. And what we just want to do here is add this tool button and this slider inside a row layout. And that's all we need to do. Let's run it now, and we see that now we have the tool button on one side, the slider on the other side. Okay, let's finish configuring the slider that we're going to use later. Slider. Let's say that's minimum value of 1, maximum value of 8. We want to show tick marks, true, and step size of 1. Now, to the split view. The split view, what it does is that it takes its available size and distributes it between its children. So here the image doesn't seem to care much about how much width it gets, and probably the tab view or someone inside the tab view is saying, hey, give me all the space possible. So as we already imported our layouts module, we're going to use the layout attach property to specify a minimum width for both the image and the tab view. Now I will run it. Okay, first notice that our slider is now configured. And I will run it. We have here some empty space on the left side. And that we can resize, and it will respect both minimum widths for the tab view and the image view. So for now, we're not doing much, but we already have most of the UI. No, sorry, I wanted to fix those. Let's run it again. I wanted to fix those margins here. Where we can see here we have not much margin between this tab view and the handle, the split view handle, and inside the tab, each tab, we see that there's not much margin with the table view and the frame of the tab view. So let's add this. First, let's add some spacing around the tab view. As I say, the split view is just distributing the available width between its children. So we can't say that the tab view, I just want the available width, but not all, just leave some margins around. The easiest way to do that actually is to wrap the type view inside an item, say that this item has a minimum width of that much, and then have the type view field its parent, and let's only add some margins. Now if we run it, we have these margins around. We can do the same with the tab, the table view inside its tab, and we only need to do it here inside the tab. Now we have it nicely done. We have image view here on the left. We have visible tab view that doesn't collide with this handle, and then some spacing of the table view. And the histogram here is still empty, so but we will come to it. Now, the further UI is actually almost complete, except for a few details. The UI itself is almost complete. So what we want to do now is add some logic. Let's start with the toolbar. Here, what we want to do is, with the tool button, what we want to do is use it to open a document, an image, and show it and run the histogram object later on. And so what we want to do is on click, and here we're gonna say open a file dialog, and whatever gets selected, assign it to our picture element. So for the file dialogs, it's already a different import. So click dialogs. And we want here is file dialog. Given that ID file dialog. We can give it a default folder. It's going to be user and pictures. And so the file dialog will emit signals when the user accepts or cancels the dialog. Here we are only interested on the accept signal. So when the user accepts, says OK, open this file, what we want to do is that the picture source will be our file URL. Now the only thing left to do here in the tool button is to say file dialog open. Okay, let's see if it works. We click tool button. We got the file dialog open here. Let's select this image, and it's displayed. Good. Okay, let's take this resizing issue, but basically it's working. The resizing issue is just field mode here, image the reserve aspect. Now, we also want, apart from the tool button, we also want to access the same thing from the menu, right? So let's add menu item, text, maybe open. Then on triggered, well, we want to do basically the same thing as the tool button here below. So here is actually the same action. Both the tool button and the file, the open menu item are doing exactly the same action. So we can abstract this away with an action element. So the action element is going to do the same. We can actually copy these things from tool button. Trigger. And when it gets triggered, when it gets triggered, we open the file dialog. We can also assign it some text, open image, and even a shortcut. Okay, so a menu item, we only need to bind this action to, I forgot to give it a name, open action, and we assign also the action property from the tool button to the open action. Notice that we also can override here a few elements in menu item if you want some further customization. But let's run it and see how it works. So if I press the tool button, we get an image. We get the file dialog in it. So press the file, open menu item. We also get an image. We can open this button now. And if you believe me that I'm pressing the Command O or Control O shortcut on my keyboard, we also get this file dialog, and we can open an image. Good. Now, excuse me. Now, as I said, the goal of this small application is to show the histogram, some histogram data on this image. So before going and starting implementing the histogram and everything else, let's take a step back and think about what would be a good API for a histogram object in QQuick, because that's where we're going to use it mainly. So let's suppose we have a histogram object and how we would like to interact with it. As you may know, histograms, well, first needs the image source, right? And this would be the picture source URL that we had already. Also, histograms can be computed more or less with higher or lower granularity, and this is what we call the number of bins. So we group the intensities by bins and we compute it so that, well, for whatever reason, we may want a simpler histogram and do some faster computation later. So the bin count is going to be this expression. Well, it doesn't matter really what it is, but now the image can be arbitrarily large, right? And we don't want, maybe we want to trigger the histogram computation manually. But we still want to do it in this case when the image source changes or when the bit count changes. So we are in the right, so to speak, to expect change signals for image source and bin count, those two properties we just figure out we may need. And we're in the right to expect also that we can call a compute function that will update or will trigger computing of histogram content. And the same way, maybe this thing takes a bit long, or it can be computed in an asynchronous way. So we want something back to signal us that the histogram has been updated. So we suppose that we have this histogram updated signal. And here, maybe we can do some computations on it or inspect it. Or so let's suppose that we want to display all its the whole data inside the histogram. So here basically we iterate over the number of bins and we display. We can display the bin number, and we can assume also that we have accessors inside the histogram to get its values. So this more or less defines our API in an example way. I'm not saying this is the perfect API, or if you haven't implement an RGB histogram, you should do it this way. This is just to illustrate that. Let's think from QQuick, and let's move and see how we would like to interact with this. So how do we get this into C++, or how do we get C++ to expose all these things? Well, it turns out that it's relatively straightforward. First thing you need is have your class inherit QObject. This is mandatory. This is the way that the QML engine gets access to inspect the class. If you have a property, just define it as QProperty. You have its type, the property name, as you will see in QQuick, and then you define the setter, the getter, the setter, and the change signal. If it's a public slot, it will be immediately available in QQuick. There's nothing else to do. Same for signals. And if it's a function that returns a value that it's not a slot, just prefix it with QInvocable. So that's what we're going to do. But actually, it's already done. You may expect that I'm not going to implement the histogram, the code here. It would be a bit too dangerous to do it live. But let's see this. So here it is. Here's our RGB histogram implementation. This is the header file. See how we have our image source property. So here we have first the type. This, as I say, the name as it would be seen in QQuick. This is the getter function. This is defined down here. This setter function defined further down, and this is the image source change signal that will be emitted every time we update this property value. Same for bin count, and here you notice that there's a read-only property. Doesn't mean it's constant. It means that you just cannot assign it from outside. This is a way of restricting API, for instance. Here are accessors, as you can see them, just prefixed with QInvocable. And let's inspect that, for instance, the image source setter. They all start with this pretty simple template. We check if it's the same value. If it's not, we assign it, and then we need the change signal. And yes, it needs to be done manually, but it also means that you can do some pre-calculations. Here it's in the bin count setter. You can do some tidying or until everything is ready, and then you can safely emit the signal. Also, here's our compute function. This, as we saw, is just a plain slot. We don't need to do anything else, and it will be available. But let's see how it works with first this histogram updated signal that we're supposed to emit after we're done computing the histogram values, and also with this read-only property. Remember, I said it was read-only and not a constant property, so it is supposed to change over time. So first we check that the image source is not empty. If it's an image, we try to get it from a local file, and we expect that it's not null. Then we reinitialize some internal data. Here is the histogram values computation. It's just scanning each line, each pixel of the image, and incrementing the values of the histogram internal data. And finally, this max value. Max value is just to find which value has the higher amount of pixels in all the red, green, and blue channels. So we just iterate over all the bins, and once we're done with that, this is when we emit the max value change signal. This is when you need to do it, because this is when it gets its new value actually. And when all this thing is done, we can emit the histogram updated signal. We should make sure that everything is in a consistent state before we can emit such signal. Now, so now we have this class. We need to make it explicitly available to our engine. So we go back to the main CPP file. We're going to include this QML header that includes everything from QQuick, and we're also going to include our RGB histogram header file. And once we have an engine instantiated, we can call a QML register type. This is a template function that takes a template parameter, the class we want to register, C++ class we want to register, and a few other parameters. First, the import statement we like to have for this type. So let's suppose that we are on a new cool startup called pixmix.io, and what we do is just we use a reverse URL notation, and so the import statement or the import URL will be io.pixmix.imageAnalysis, because it's the image analysis of our maybe broader framework. This is our version 1.0 of our module, and the type name in QQuick. So there's nothing wrong with giving it the same name. So that's what we're going to do. And last step is just importing the right module. Pixmix image analysis 1.0. All right. Now that we have this histogram, and we can almost finish the last step, that RGB, the histogram view that we're missing. And this was prepared in advance, so we don't need to do anything now. And we call this histogram here. So we have this histogram. We're hoping that all this API is going to work, that we're not going to get any error. And hopefully, if everything works, we'll get a nice view of the histogram here in the second time. Let's run this. It's a lot of changes since last time we ran this application. Okay, let's open a file. It is, well, the table view we haven't done anything, so it's not displaying anything. Let's see the histogram. Oh, this histogram looks a bit weird, and it's because it only has 2 bins. So let's increase the number of bins up to the maximum. As you can see, here it is. We have a histogram. We also saw how the histogram was changing, where the bin count was changing. Remember, this slider was the slider value is bound to the bin count property of our histogram. And let's see if it really works, because if we change the image, we should get a different histogram. So we've done a lot of progress in just without changing much of our QML file. Obviously, there was all these C++ things behind going on, but we haven't changed much our UI file. It's just added a few objects, and that's about it. Our table view is still a bit sad. It has nothing to show, so we're going to help it. So table views are basically just list view with columns. A table view is not something you're going to use to implement a spreadsheet. It's not designed for that. So what you want to do is just define which columns you're going to show into this table view. The first column, the title, we're going to use this. Let's give it a width of 50 pixels, and it will try to get a model and then fetch a role from it. So for each row in the table view, we assign different roles into each column. So the role for the first column is going to be the number. Second column is going to be our red. Let's make it a bit wider. Our red count column. The column is going to be green count. Scroll a bit further. And that column here is going to be a blue count. Now, last thing we need to do is assign the model. So let's suppose we have a hist model here to our table view. Let's create a quick model for it to show. We can, for now, this is something you should not do in production code, or you're highly discouraged to do this, because it's just not very efficient. But we can do it for the sake of our little experiment here. So we're going to use a list model, and what we're going to do is clear it, and when the histogram is updated, we clear it, and then we're going to populate it again. So what do we need to do? List model, and here, and what we populate it with is just JavaScript objects. So number, and what happens is that the JavaScript property names will be mapped as being those roles we want in our table view. Or we want in our model actually. So this JavaScript object here, notice the curly braces, has 4 properties, and I misspelled number here. And each of these properties will be mapped as a role inside the model, and each role from the model will be mapped as a column in our table view. So if I didn't do any major mistake, or even minor mistake, this thing should work. Okay, let's see now that the table view is very different now. It's showing columns. It has hopes of showing some content at some point. So it's already showing some background thing. So let's open it. Open a new image, and here it is. We have some data to show. And notice how, as I increment the number of pin counts in our model, we're also having more rows into our table view. So table columns can be resized and can be moved around and so on. But as I said, this is a very ad hoc solution. Normally one shouldn't do that. Because it's very costly actually. It's creating all these JavaScript objects, and then updating the model continuously and so on. And do we really need this? Why don't we do just this? Say that the model for a table view is going to be a histogram object. And then what we want to do is remember a histogram class. Instead of inheriting from the object, we'll make it inherit from a QAbstract list model, since table view, let's say, is mostly a list view, and implement the virtual function we need to do.
Just to not to stop you, but to slow you down for a second, Gabriel. So, getting some questions that why the model is discouraged from production. So maybe you could clarify what was it you meant. What are you encouraging and what are you discouraging people from doing in their production code?
Oh yes. So, well, at least as it is implemented here, what happens is that, well, instantiating, create a new JavaScript object is a bit expensive compared to not having to do anything. This is one thing. Second thing is that every time we call the append function, we are emitting a model change. So this list model here is getting a model change. So every time we call append, we trigger basically an update of the whole table view. And this is not something you want to happen. Or I mean, it can work if the model is very small, but don't expect good performance if you have a few thousand items in your model. Good?
Yeah, absolutely. Thank you very much.
So, yes, I was saying, so instead of getting this model, maybe we could do this with our histogram model and inherit our RGB histogram from QAbstract list model, implement the functions we need to implement, and hope that everything will work. Well, actually, this, as you might have suspected or already seen, is not a good idea. Mainly because, well, maybe RGB histogram is not inheriting the object directly, but it's inheriting something that inherits the object. So you cannot make it inherit QAbstract list model directly. And having multiple inheritance in this case would introduce most likely a diamond pattern. So that's something we don't want to do. And maybe we just plain simply don't have access, or we don't want to support having to change the RGB histogram API. It's some module, and we don't want to change that. So what we want to do is have a separate model object, so that when we have a C++ object, it will communicate with this QML model. And when we hook this QML model into a table view, for instance, it will send signals to the table view saying, okay, these rows have been updated, or these things need to be changed, or and so the table view will query the model, what's the data for row number 5, let's say, and the QML model will query the C++ object, and so on. So what we want to do is this: is leave alone our RGB histogram class and just implement a separate RGB histogram model. This one will only need to have a histogram property, at least for this purpose, which will refer the histogram that it's proxying, and also implement the mandatory functions from QAbstract list model. So, as we said, here what we want is just RGB histogram model. Let's call it his model, and histogram property will be here. As you might expect, this is already implemented on here. And if you look into it, we can see it's pretty straightforward. It's just defining histogram property. Notice how we can go back and forth here between C++ and QQuick. How histogram, RGB histogram type or class goes back and forth in a almost transparent way from QQuick to C++. In here we have this hist object or histogram property that gets assigned this object here that is defined in QQuick, and it is transparent how you get it here. So when the setter set histogram is called, we get immediately an RGB histogram. We don't need to do any type conversion or object conversion. And what we do here is pretty straightforward as well. We connect the histogram updated signal to our own histogram or the model's histogram updated slot. And what happens here is that we just reset the model. It could be done in a more smart way, but for this purpose, it's all the same. Also notice that, yeah, in the end, we don't need to instantiate any new object anytime while we're accessing data from the histogram. Let's look also the key abstract list model methods we need to implement. There's this role names hash we need to return. That's the one that's going to map the internal C++ roles for our model into these role names we access from QQuick. Row count, well, we query just for the bit counted at histogram. And the data function just looks at model index row property, and it just gets, depending on the role, that is the bin number that we're querying, or the red, green, or blue count row. Well, we also need to do the same thing we did for our RGB histogram class here. We include the header file, we register the type, and we can have a different import module here, but well, let's say it's not there right now. Since we already imported that module there, it should all work. Let's see if it's true. Let's run it, build in everything. Okay. Here are a few changes, but this is a bit residual. Maybe our histogram model could be implemented a bit cleaner, but basically it's showing some extra data. But if we open an image, what we're interested in knowing that, yeah, indeed it's displaying data from the histogram. And as we increment the number of pin count, the number of pins, sorry, we see that, yeah, it is fetching the data from the histogram. And our histogram looks always the same. But we did this. We need to test also that if we change image, the histogram values change here in the table view. So it looks like everything is working, and which is relieving, so to say. Okay, so that's basically it. We've seen how, let's see, a bit less than 120 lines of code, we can implement a full application. Okay, it's a very simple application, but it does quite a bit of things for 120 lines. Because again, seeing how to go back and forth from QQuick and C++ a bit, and the interest of having a model object. So that's all for me. So if thank you for your attention, and if you have any questions.
Oh yes, I think I have quite a lot of questions. I think several people asked about the database support and the interaction between C++ and QML early in the presentation, so you probably saw what's coming. I think you demonstrated very well how to connect the dots between C++ and QML. I don't know if there's anything more you would like to add on that.
Well, for instance, database support. I'm not a big specialist on which Qt native database, or not native database, but any Qt model that supports database, I'm pretty sure there are. But in worst case, if you have your own, or the driver for your database doesn't exist, what you can do is just implement the same thing we did for the histogram model, implement your own model, and then plug it into your database and make those roles or whatever data you need to be visible.
Mm-hmm. And then there's a number of people who have been asking about the source code for this, if this is a project that they could get their hands on, if they could check it out.
Yeah, it's right here. It's not the latest version you get in this URL, but it's in the current slide URL, so you can visit my GitHub.
Okay. And there's another question on QML, more on the details of Qt Quick and components and versioning number of the different components that you have been using. If you have any tips on how to if you have a larger project with different files, importing.
Yes, I see what you mean. Yeah, this is something that's been a bit under discussion, and it's not something we can change right now. The versioning number was introduced to avoid name clashes in future versions, or make your own code future-proof, so to speak. Let's say that you are defining a new type because it's missing in HTTP controls, and if you update your import number, then suddenly this type can clash with some new type that's available in Qt controls, so that becomes available in Qt controls. So yes, it's not easy to manage, so to speak, if you have a very large project. But unless you really need this new type, then you will add it. You will increase the version number on that file and use it there, and that's it.
Okay.
There's no point, or there's not really big interest into having to the latest version all the time. I mean, yes, you will get the latest version, but there's no point or interest into using the latest import in your code.
Exactly. Another question was with path names that you were using. They seem to be very Mac-specific path names. Are there any way of using platform-in-specific or platform-neutral paths, such as home directory or other getting to certain other directories in a non-platform specific way?
Good question. I have to admit, I don't know.
Putting you on the spot there. I'm sorry about that.
I know they exist in C++ side, but I don't remember for sure in the Qt Quick side. Worst case, you can always create your own interfacing, but it is something that should definitely be available in a way or another.
Okay, so I think the question is yes, but neither of us know right now. So we were both put a bit on the spot. Sorry about that, people. And I know that you also walked through this in the beginning, but for the different designs, there is a difference between the row and the row layout, etc. There seem to be some people who didn't necessarily quite catch what the difference there was.
Yes. Well, the difference is very simple. Row just takes whatever children it has and just put them one next to the other, and it will all put, unless you specify yourself some vertical offset, it will all keep the 0 y coordinate. So they will be all basically top aligned. In this case, what we wanted is the slider and tool button to be nicely aligned. And what row layout does differently in this respect is first make sure that the controls are nicely aligned, along their baseline. Another thing that row layout does is that it's possible to specify minimum and maximum width in for each of the children, so that when the row layout is stretched, it will distribute those widths among them. Something that the row component doesn't do. The row would be more manual in this sense.
Exactly. So slightly different use cases.
Yeah.
One is a little bit more low level, and one provides a little bit of simple out-of-the-box features. Row layout is kind of helping you, holding your hand a bit for what we consider the standard use case.
Row layout is really a layouting thing. A row is just a positioner. It just puts things one next to each other. A row layout does layouting does much more. Yes.
And then working with Qt Quick as a UI framework, there were some questions if there are any kind of drag and drop tools similar to Qt Designer available, and what the roadmap is for that. Now I know you're not working on the tooling side specifically.
I know, but we already have some the latest version since I don't remember which version number, maybe Qt Creator 3. I may be wrong in the version number, but this Qt Creator does have a Qt Quick Designer. When you open a QML file and move to the Designer tab, you will be inside that Designer automatically.
Exactly, and the maturity of that, I guess it's not exactly on the same level as the widget-based Qt Designer.
For obvious reasons, yes. But I know that our team in Berlin is working hard to get this up to date.
Exactly. So the first session this morning was with Tobias from the Qt Creator team. He wasn't talking specifically about that, but that is a part, that's one of those plugins that is undergoing quite a lot of work at the moment, and there will be updates to that. Now this was more in the beginning of the talk, so I can't remember if you actually followed through with all of that, but there was some questions regarding the tool button and what options you had there, if you could add images to a tool button and names, etc. I don't know if you would just want to...
Oh, yes. There are a few things that are missing for the tool button, but yeah, the image source is basically, I don't understand images, but what do you mean by images? But
icons or?
Well, yeah, you have this icon source, and then you assign whatever icon you have. So you will display the pixmap you assign here or the pixmap that's at the URL you assign as property here.
Exactly. And then there was a question, a lot of people have been using Qt Quick for the mobile use case and styling them to look like mobile apps. But for the desktop, it looks like you're working more on a native look and feel. Are there any options or availability of styling and creating your own styles, or using pre-created styles from us also on the desktop side?
Yeah, this is something I forgot to mention. Since Qt 5.4, Android also gets its own native style for Qt Quick controls. So yes, if you develop your mobile or Android application using Qt Quick controls, you will get this native Android style. We also have other styles. Yes, it's something that didn't go through during the presentation, but for instance, we have this flat style here that is will be ready for Qt Quick enterprise controls, and it's just a regular, the same Qt Quick controls with just a different style. And so it has a few other controls available also as an enterprise offering, but all the controls are stylable, so you can change and really make them look completely different. Here, this button is the same button we've seen before. What is there? Yeah, this slider is the same we've seen before. It's just the style is different. And yes, if you really want to come with your own style and change things dramatically, you can do it.
Absolutely, that's a very good question. No, that's a very good answer, and I think this flat style is a very nice indication of how we've been using the styling API to create our own style, and you can do that yourself as well. And this is obviously something that's with the enterprise version of Qt. So if you're interested in some additional features and some additional handholding, then enterprise is obviously always a good choice. I had a last question, and that was regarding debugging QML code. Is there any way of adding debugging information or debugging the Qt and the QML code?
Yeah, there should be integration when you run your QML application. You can put breakpoints there, and just make sure here in your project, when you run it here, at the end, let me hide this, you have enabled QML for the debugging settings here at the bottom of the screen. And it should basically work. Just put breakpoints there. You have some JavaScript code or a small function. You can put breakpoints and trace and whatnot. You also have analyzing tools, so you can trace when this object is getting created and destroyed and so on. So yes, the tooling around Qt is coming up nicely, and yeah, we're trying to bring it up to the point that it's as good or better than Qt widgets.
Fantastic. Thank you very much, Gabriel. And with that, I think our time here is up. So also, thank you very much, everyone who has been listening to this session. Remember, if you have any more questions, we'll try to get back to you as quickly as we can. Go to qt.io if you're interested to look at our web pages, and yeah, just buy our license and get started. So thank you very much.